Hey, Algebra 2 classes. Well, welcome back to one of my videos. This is the long-awaited chapter that I've been promising you that's going to open your eyes to these kinds of problems. When you see them on the ACT, you're going to know exactly what to do. Okay, so we're going to start with chapter 7-3. Okay, and we've covered exponential functions. We've covered how to graph them, how to solve exponential equations, how to solve growth and decay problems, mostly growth with money and compounding interest. We covered that yesterday. So this is for Wednesday. Okay, we should be on Wednesday, and that will be March the 25th. Okay, whoops, 25th. All right, and that's what lesson we're on today. All right, so I'm going to start with this, and we're going to build on the fact that we just covered exponential functions. And you'll remember in exponential functions you have y equal to some base raised to an x power, which is your independent variable. Okay, remember when we talked about inverse functions? If we were to write the inverse function to this exponential, remember x and y would just change places. All right, the inverse to the exponential function. All right, x and y would change places, remember? So it would look something like this. X is equal to some base raised to the y power. So now we have the inverse, and this guy right here, the exponent of the inverse function to the exponential, okay, this is called a logarithm. Okay, this is the logarithm. This is an exponent that you raise your base to equal your x. You could see the difference between the exponential function and the logarithmic function. Okay, so the logarithmic function is simply the inverse to an exponential function. The value of the logarithm is going to be whatever this exponent is here. All right, so what you have here is the exponent form of a logarithm. Now, please do not get this confused with exponential form, because the logarithmic statement is the inverse to the exponential function, okay? But this format right here is called the exponent form of a logarithm. That's when you have some value x equal to a base raised to a power y. All right, so the inverse to an exponential function is called the logarithmic function. All right, so we're going to expand on this, and we're going to take these expressions and we're going to write them first in exponent form and then in log form. There's two ways to present a logarithmic function. All right, but I wanted to give you the basics. Now, as far as graphing is concerned, you can certainly put these in your calculator, use the button log to graph any of these, and you're going to be able to graph them. I'm not spending an entire video on graphing logs. Number one, we don't have time. Number two, you've got your calculators, and you guys are savvy enough to put it into your calculator and graph a logarithmic function using your calculator, and you can refer to the table of values, the XY table as well. So I'm kind of jumping past that, and I guess that's just something that I had to make a call on. All right, so let's start talking about how we can write and rewrite these. First, I'm going to show you, this is what we call log form. That's short for logarithmic form. And this is what we call exponent form of a log. Okay, these are the same thing, just written different ways. I want you to be very comfortable, okay, with going back and forth between the two formats. All right, so I'm going to write a couple of these very easy examples. All right, so in log form, I'm going to make a statement. I'm going to say log base b of x equals y. All right, I'm going to show you how to say this. Now, this base is kind of a little, it's a subscript to the g. Let me write that a little bit better, guys. Log base b of x equals y. Okay, I'm going to write out the words how you actually say this statement. Log base b of x equals y. Okay, so instead of a b and an x and a y, I'm going to actually replace those with values. But first, I want you to understand something. Well, let me go ahead and just give you an example. All right, log base 2 of 9 equals, sorry, make that a 3, equals 2. Okay, log, I'm going to say, this is how we're going to say it, log base 3 of 9 equals 2. Log base 3 of 9 equals 2. Okay, what does that mean? That means that the value of the left-hand side is equivalent to the exponent necessary to raise this base to that power to equal that value, that x value. So if we were to write this in exponent form, what happens is you simply are going to lose the word log. The base is going to swing over, and it's going to push this exponent up into exponent position, and it's going to look like this. 9 is equal to my base, he swings over, 3 squared. So as stated before, this is the exponent value. This is the value of the logarithm. Okay, this is the value of the exponent that raises this base to equal this number. Now I have a name for this number, and I'm going to, on the next page, we're going to talk about what I call this. And it goes back to my history or my days of teaching at Collierville, when there was a woman there, she was a teacher, and I said, you know, I just don't know what to call this. Well, actually it's called the number that's being evaluated. Well, who wants to say that 8,000 times, right? So she said, exactly. And she said she named it after herself. And her name was Miss Brock. So we call it the Brock. So in this class, in Miss Smith's class during logarithms, we're going to refer to this guy as the Brock. Okay? So I'm going to go to the next page. We're going to use this same expression, and I'm going to explain again how to go from log form, when the word log is actually written, to exponent form of a logarithmic function. Okay, so let me change pages here. So let me just kind of identify, like we just did a minute ago. So log base b of x equals y. Okay, so in log form, we have the word log. This is your base. This is the base, and you know bases are always going to be raised to an exponent. This right here is the value I was talking about a minute ago. We're going to call this the Brock, okay? Just because it's an easy one-syllable word and I like it. I've been doing it for 11 years this way. So we'll call this the Brock, okay? And you don't have to tell anyone outside the math classes that we call it the Brock. I'm telling you that because I want you to get used to knowing, okay, what number is she talking about? But this is actually the number that's being evaluated, all right? This is going to be the exponent. All right, so this is the base, this is the Brock, this is the exponent. All right, so let's go back to our example. Log base 3 of 9 equals 2. All right, log base 3 of 9 equals 2. All right, that's how you would actually verbally describe this. All right, this is the base. This is the Brock. This is the exponent. All right, this is in log form. Anytime you see the word log, that stands for logarithm, you are in logarithmic form, okay? Or log, yeah, you're making a log form, and we're going to move it to exponent form. To move to exponential form, not exponential function, exponent form. Let's just call it exponent form of the same statement. We're just rewriting, okay? So rewrite to exponent form. That means the word log disappears, okay? So by log, base is now cut off from log. He has to go somewhere. So he's going to migrate over to his exponent, and he's going to push that exponent up into exponent location. So the only thing left is over here is the Brock is equal to your base raised to the value of the logarithm. In this case, it's the value of the exponent necessary to raise your base to equal your Brock, okay? So we're going to take some rewrites, and you can have positive, negative exponents, that kinds of things. All right, now, something I want to point out. Let's go back to this. The value of your Brock, okay, can never equal 0 or a negative. All right, so the Brock clearly has to be greater than or equal to 0. Why is that important? Well, sometimes you'll have a variable as your Brock, and you have to make sure that your answer doesn't violate, if you're solving, when we get into solving these equations and you solve for x, and you plug it back in here and you're left with a negative Brock or a Brock of 0, okay, then you're going to say no solution, because the Brock has to be greater than or equal to 0. Because think about it. If this is an exponent, and I'm raising this base to this exponent, okay, there's no exponent that I'm going to come up with that when I raise this base to that exponent, that it's going to leave me with a 0 or a negative number, okay, in the Brock. So hold on just a minute. I've got to stop and pause.